This is video 491, and the goal of this video is to use trigonometric models to answer questions. This is similar to what you'll do for your projects. So take some good notes, write some questions down if you're stuck at any point. But this is very similar to what we did in class today. We're just kind of summarizing it here with another example. So first, let's take a look at this first question. Just a quick note, it is a question from Australia, so it's got some weird spellings in there, but we'll make it work. So we have a rule to model the tide above mean sea level. The first step, graphing it, is always a great idea if you're trying to answer questions about a rule. And that'll help us confirm our answers to questions B, C, and D. So taking a look at the sketch of the graph, I'm going to go fast through the graph. So I know two things. I know that the period is 6 and the amp is 3. And I found the period by doing 2 pi divided by pi over 3. And I'm going to make a sketch. There's no shift, vertical or horizontal, so that's easy. So it's going to start at 0, 0, and go up and then come back down. So I'll set up my axes up to 24 because it asked me for the next 24 hours from t of 0 to 24. And I'll sketch my wave. So I see it looks like there'll be 4 high tides and 4 low tides. And now I'm ready to answer some questions. Question B is fairly simple once I have the graph drawn. It's going to be right in the middle of 0 and 3 hours, so at 1:30 in the morning, an hour and a half after the turn of the day, it'll be at 3 meters. What is the height at 2 p.m.? So 2 p.m., remember, that's 1400 hours after midnight, if we think about military time, or 2 hours after noon. And so I can see it on the graph. It looks like it's around 2-ish. I can't quite tell exactly what it is, though, so I have a good estimate that it looks like it's about 2 meters. But in order to find what this actual value is, I'm going to plug in a value. So I'm going to estimate 2 meters because of my graph, but since I sketched it, I'm going to plug in 14 in order to find out what it is, plugging in 14 for t. And now I simply evaluate this by plugging it into a calculator. I could plug it into a calculator, or I can get the exact value as you'll see here, because 14 pi over 3 is coterminal with 2 pi over 3. I simply subtracted 2 full circles there. So I know the sign of 2 pi over 3 is square root of 3 over 2, which means that this value will be 3 times square root of 3 over 2, because it was 3 sine of 14 pi over 3. Now that's the exact value, but since we're in real world, we're going to plug that into our calculator and get 2.59. Yes, you could have plugged it into your calculator right here and gotten the right answer. Not a problem. Now let's take a look at the next question. The next question is a little bit opposite of this. We're trying to find actually what time we will get the height greater than or equal to 2, because we want to be at least 2 meters above mean sea level. So now we're going to plug in. What I'm going to do is plug in 2 for the height. I want the height to be 2. And then we'll look at the graph to kind of think about what we need to do next. So I'm going to solve this equation. The first thing to do always with solving trig functions is to get the sine function alone. So I'm going to divide both sides by 3 to get the sine function alone. My next requirement is to get rid of sine. Sine is on the outside of this whole function. You don't get rid of pi over 3 yet because it's inside the sine function. Sine is on the outside, so to undo it, I'm going to do sine inverse of both sides. And I get sine inverse of 2/3. Remember, that's asking what angle has a sine of 2/3. And that angle has to equal pi over 3 times t, because that's the angle I'm looking for. Now I'll have one more step to solve this problem. I'm going to times both sides by 3 over pi because it will cancel the pi over 3. And that value inside that gray box is the answer, but of course, again, this is real world. I'm trying to find an actual number, so I'm going to plug that into my calculator and get 0.696. So that means at 0.696 hours after midnight, so just over half an hour, almost 45 minutes. Almost 45 minutes after midnight, I will have a height of 2 meters above sea level. Now, the question is, the hard part about this is there are actually 2 angles that have a sine of 2/3. There are 2 angles that have a sine of 2/3, and they are pi apart. They are supplementary pairs. And that's something that we summarized in class today. So the other way we always find for sine that we find our other value is by doing pi minus that angle, because that's going to bring me to the other side of that unit circle. If we think about the unit circle, and we landed here for the first angle, The other angle is over here, and they have the same exact y values. And so those angles are related by a supplementary pair. Because remember, my first angle is this small one right here that's in the range of sine. My other angle is identical reference angle, but it's this large angle that goes all the way from my initial axis to my terminal side here. So it's the angle that's supplementary to it. So pi over pi minus sine inverse of 2/3. So we always have to do this. Once we take the inverse, we have to find the other angle right away. And we still solve an equation equal to pi over 3t. And of course I got that because when I take the inverse of this on both sides, that's what I get on the right-hand side. Now, solving this, I'm going to first change this first part to a decimal because, again, we're talking about real-world stuff, so we want exact values. We end up getting 2.4119 equals pi over 3 times t, and of course, same process, I'm going to times both sides by 3 over pi. Plugging that into my calculator one last time, I get the time equals 2.3. Now I look at my graph and I start to think, does this make sense? Does this seem right? So there's about 0.696 and 2.3. Okay. One other reference that we have is that at 2 p.m. it was 2.59 meters. And so this should make sense that at just after 2 o'clock, 2.3 hours later, it was at 2 meters high, a little bit shorter because it's a little bit later in the day. Now, of course, I'm using this same wave that was here to mimic this wave that was there. So now these are 2 hours. These are 2 times that work, but of course they reoccur 1 period later, or in our case 6 hours later. So this constantly happens. Looks like you see it 4 times in this 24-hour period. So we're going to have this happen 4 times. So, and it's 6 hours later, 1 period. So we have to know the period in order to find the other values. So our first answer is between the hours of 0.69 and 2.3 hours after midnight. That's the first section where we will have something greater than 2. But now we got to find the other sections. Well, there's 6 hours later, so at 6.69 and 8.3, all I did was add on 6 hours to go the next period of the function. And then I do it again and again. So I'm adding on 6 hours altogether 4 times to get all 4 sections. So hopefully you're seeing that the graph is very helpful to analyzing these situations, but also we need to know things about sine, and that sine repeats itself, that we have this supplementary pair here. So those are the solutions. I can convert them back to hours, but these are the hours after midnight that those tides will occur for the ship to cross the harbor. Now you're going to take a look at your checkpoints. So these are a little bit easier than that last question, but just make sure you think about what you want to plug in and how a graph will be helpful for you here. But remember, once you submit your answers on the checkpoint, the solutions will be there so you can check your work right away. So good luck, bring those questions into class, and we'll be practicing one more day of this before your project will be due.